I was just reminding everybody in the class that these are the summer classes I teach, in case you're interested. Making decisions. We already know all about making decisions, and I can't believe that we're not already done with this chapter as well. We've been talking about it the entire time. This is like a one-day lecture, except for the fact that we're going to do some reviews, so it's going to cut our day in half, right? Because my programming style is the first 3 chapters of the book, I give you all a lot of so-called extra information because they mention a topic, but they don't cover it well. I go ahead and cover it well so that when we hit the official chapter on it, it's a breeze. It's the second time you've seen it or the third time you've seen it. So making decisions. We're going to learn about the selection structure. We know what it is. It's if and if else. Relational comparison operators. Well, that's a fancy term. All it just means is greater than and less than and equal, stuff like that. And, or, and not. In your heads, you already know what those things are. I am sick and tired of this, right? That means that I'm both of those. I am sick or tired. Well, hopefully one of those is true, but they don't have to both be true, right? If I have money and I'm hungry, I'm going to go out to eat. That means that if I'm not hungry, I'm not going to go out to eat. And if I don't have money, I'm not going to go out to eat. So and requires both sides to be true. Or works a little bit differently. If I am sick or tired, I stay home from work. Nice job, huh? So, if I am sick, I stay home. Or if I'm tired, I stay home. Doesn't have to be both. So I'm going to add those to some notes that I'm taking up here. So X and Y. Both sides, parentheses, operands, must be true. So something like this. If X equals 0 and Y equals 0, print, yep, zeros. Something like that. And means that both of those had better be 0 or else we're not going to see the answer. We're not going to see the print. Apparently I didn't start these off with a comment, so if we can actually write some code, I better comment all this stuff out. So, both X and Y better be 0 if we want to see the print happen. Fancier way of saying that, both expressions had better evaluate to true for the whole thing to evaluate to true. Both X and Y had better be true before the whole thing evaluates to true. Or is a little bit different. X or Y. Now, I didn't really mean to repeat the use of these variables. That X doesn't mean anything attached to that. So, I'm going to rewrite this a little bit. If A equals 0 and B equals 0, and then both A and B had better be true. Had better be 0 if we want to see it. Why did I do that? Because I don't want you to think that there's a connection between X and Y and this. These just represent two sides. Two operands of the AND operator. So, or. Either side, only one side, must be true for the result to be true. If A equals 1 or B equals 1, print, yep, ones. What does that mean? Only one side has to be true. If A is equal to 1, or if B is equal to 1, print the message. So you get the idea. And requires them both, or just means one. And if they're both true, so much the better, right? But only one was necessary. I'm going to make what's known as a truth table for this, and I think I've already showed you all this. But it doesn't take much time to create, especially when I have Word already open. So if we have X and Y, so that's the X column, that's the Y column, that's going to be the result. And there's really, only 4 options. If you have 2 variables and either one is true or false, then you only have 4 possible states. You have false, 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 true. You have true, false, and true, true. Forget those numbers in the 3rd column. They're going to go away in just a second. Right. If you replace these with zeros, it looks like counting in binary. I'll just demonstrate that by copying this little chart. Yeah, don't need that, but you have 0, 0, 0, 1, and if you kept counting in binary like we did on our binary car, our odometer, 1, 0, and 1, 1, right? So 2 bits give you 4 options. 1 bit only gives you 2 options. 3 bits, 2 to the power 3, gives you 8 options. 4 bits gives you 16 options. But we're only talking about AND, which has 2 bits, 2 operands. Okay, so AND requires both sides to be true. So a false and a false just equals a false. A false and a true, well, both sides are not true, so it's still false. A true and a false, well, both sides are not true yet. This is the only time when AND works, is when both operands are true, when X and Y are true. I am hungry and I have money. I can go out to eat. So that's the X, that's the Y, and that's the result. I'll post this document. So OR looks a little bit different because only one side has to be true. So here's the OR truth table for X or Y. Get rid of all these because we're going to rewrite them. Now for OR to be true, only one has to be accurate. Only one side has to be true for the result to be true. I am sick or I'm tired, I get to stay home. But if I'm not sick and I'm not tired, and both of those things are false, I'm not going to stay home. Because neither side was true. I'm not sick, but I'm tired, I'm going to stay home. Right? Because at least one side is true. I am sick, but I'm not tired, which is a weird state to be in, but whatever. Sometimes you just feel good and told to stay home anyways. That's true. And then I am both sick and tired, I get to stay home. That's true. Right? So you see the difference. Or the only time it was true is when both sides were true. Oh, excuse me. And the only time it was true was when both sides are true. Or it's true all the time except if both sides are false, because only one or the other has to be lit up. And when I say lit up, I mean, with electrical charge going through them. Back in the olden days, the 40s and earlier, they used vacuum tubes, which are essentially light bulbs, to hold information, right? And if the light bulb was lit, right, then it represented a 1. If it wasn't lit, represented a 0. Then they came up with more sophisticated vacuum tubes, which could support up to 10 levels of brightness, and if it was at 1 level. Anyways, so those are the truth tables. And then there's one more itty-bitty one for not. Not just reverses the truthiness, right? If I say I am not sick, it means I'm the opposite of sick, right? If I am not full, it means the opposite of full. I'm going to paste that one and just call this the not truth table. And really, it only has one column, not two. I mean, it only has two columns, not three. Dadgummit, it missed my... All right. So, the way we'd express that is we would say not x. I'm just going to delete these because I'm having trouble deleting the column and having it not mess up my chart. So the not of false is true, and the not of true is false. Right? There's only one bit involved. There's only one option being involved, and so there's only going to be two rows in my little table here. Like that. So those are our three truth tables. I'll move them all together. Put them all on, one page. Add them to our notes. Now it's looking lousy. I'm going to undo all those changes. It looked great before. All right, I'll arrange it later. So selection structure. Every computer decision has to ultimately result to either a true or false. Maybe not with quantum computing. I don't understand quantum computers. But ultimately, yes, to decide whether to light that pixel up with a certain color or to not, right? Has to decide whether the hard drive is on and doing something or not. So this is what's known as a dual alternative selection structure. Because it's got two outcomes, right? If temperature greater than 100, print hot. Else print cold. That is opposed to the single alternative outcome. If it's hot, if temperature is greater than 100, print hot, else don't print anything. So let's give examples of that in our code. Ending my comments so I can actually do stuff. Temperature is, it's really hot outside. Temperature equals 200. This is a dual alternative selection. If temperature greater than 100, print, parentheses, hot, end quote, in parentheses, else, print cold, or not hot, right? One or the other. I can't stomach saying that 99 degrees is not hot, right? I mean, it's cold, so that's why I worded it that way. And we saw what that looks like on a flow chart. It's a diamond, branches off both ways, and there's stuff underneath each way. A single alternative selection. If the temperature is less than 0, print cold, in parentheses, or in quote, in parentheses. But there's no alternative. So a dual alternative is known as an if-then-else, or just an if-else. Most languages don't actually have the then keyword, but for some reason textbooks talk about then, right? If something, then do something. Sounds good in English. So I'm going to add a comment to my dual alternative comment that says that this is an if-then-else structure. Single alternative, it just means that there's no else. It's an if-then. I better make sure I don't have any syntax errors. What lecture are we on?
Oh, I think.
Yep. So Save as Lecture O. All right. It was, in fact, hot. If I change this to something middling, like 70, let's just say, whoops, I wasn't expecting that. I thought I changed it to 70. Oh, I see what I did wrong. No, I want my limit to remain 100, but I'm going to initialize our temperature to 70. It's lukewarm. It's room temperature. So she better not say hot. Okay, it's not hot, but it's not cold yet. So it didn't print cold. All right, now I'm going to make it negative 70 degrees. We live in Siberia. Not hot, cold. Reading about something strange this morning. The largest lake in the world, even bigger than the Great Lakes, is in Russia. It's called Lake Baikal. It's the deepest lake in the world, and since it's in Siberia, it freezes incredibly deep. And then people go and they drive on it, or they run marathons on it. But sometimes the ice breaks, you know, just like geological pressure and stuff like that. Anyways, it just kind of interested me. The pictures of the ice. That's pretty cool. I've never seen anything like that because I've never lived anywhere that cold. What's that have to do with anything? Well, we just wrote something that said, you know, cold and not cold. Anybody need syntax error correction? Nope. All right. And here's a great big program showing a dual alternative if, right? We're not going to look at the source code, but we see if hours greater than work week, then indented under that there is some code. Else, there's some other code. I guess we could scroll over to the, here we go. If hours greater than work week, then, I guess in pseudocode they like the word then. I haven't been making, I'll do that. Then do something, else do something else. So that's a dual alternative if. Let's see if there's any other if statements in here. No, but I see a loop. The difference between an if and a loop is that an if has to rejoin back at the bottom. We've been putting a little circle there. They don't. A loop goes back up to the diamond again. And so I believe that Chapter 3 called that a repetition structure. This is a selection structure. So on the on the exam, I'll show you just something like that, and the symbols will be empty, right? I'm not going to put any words. But if there's something on one side and something on the other and they join below, it's a dual alternative if. If there's something on one side but nothing on the other, it drops straight down, or it goes off to the side but isn't nothing else, then there's no else, and so it's a single alternative if. And if it's a diamond that loops back to itself, doesn't go underneath it, right? Doesn't have two branches that join, only one branch drops, the other one goes back up to itself, then it's a loop. So the if-then clause. The clause is their term for what goes here. That is the clause. I would call that the expression, but I didn't write the textbook, so it's the clause. I'd like to ask you that on the exam. By the way, your really good review for it is just to go back and step through the quizzes, right? You took the quizzes. If you didn't make 100 on it or 90, then take it again, right? Otherwise, just step through it. Some of the questions are taken directly from the quizzes. And then all right, I lied. The thing there is not the clause. This is the clause, and I forget for telling, I apologize for saying that. Hot. This is the clause, the if-then clause. And then down here, this is the else clause. A clause can be one statement long, it could be a million statements long, right? We've done this before where we had a whole bunch of statements inside an if. I would call that the body of the if. So relational operators. We know what they are. 6 relational operators. Less than, greater than.
Plus, minus.
Nope, those are math operators.
Would you say less than, greater than?
Yeah, so relational operators, we have 6 of them. Let's see if we can come up with them. Less than, greater than,
Not equal to.
not equal, which implies another one, equal to. That's not equal to. I'm not going to even put meanings for these, right? And then what's 2 more?
What's the one where it's the less than and greater than together?
That is how
Is that the same
in class, in academia, you know, in your high school or junior high or whatever, you wrote not equal to, but we do it like this.
Is less than equal to?
Yep.
One?
Less than and equal to is 1,
And
and then greater than or equal to is 1. I'm going to trust that y'all know the words for all of those. The book goes ahead and shows not equal as being that, which is dumb because I've never seen a programming language support that. So, something to concern ourselves, the opposites. Which of these are opposite to the other? Some of them are very blatant, right? Equal and not equal are opposite. Some of them are a little less blatant. So like if we do this, age is equal to 18 or 17. And then we're going to write some if statements based on that. If age greater than 17, colon, print, go vote, end quote, in parentheses. Else, colon, print, no voting because we're too young. So now we're going to word it the other way. We're going to try to write it with the opposite logic because that's what I'm talking about, opposite relational operators. If age less than 17, colon, print, stay in school, end quote, in parentheses, else, colon, print, join the army. Now really I wanted the rules to be the same for both. If you're 18, you get to vote and you get to join the army. If you're 17, you don't get to vote, you better stay in school. You probably already see the error there, right, just from the way I said it. 18 and above means you get to stay in school. I mean, means you get to join the army, so doing less than. But let's prove that. When your age is 17, it's supposed to say no voting and stay in school. But it says no voting, but join the army. Apparently you're too young to vote, but you can go join the army. To make this actually work, if we wanted it to employ the opposite logic, we'd have to do that. Right? So the opposite of greater than is less than equal to. Otherwise, when you're right on that edge, the number that's being compared, it won't behave the same. Now it will. Now it's going to say no voting and stay in school, which is correct, right? And if we bump our age up to 18, then it will correctly say go vote and join the army. So I'm going to make a comment to that effect underneath here. opposites. Equal, equal is opposite to not equal. Makes sense. Less than is opposite to greater than equal. And greater than is opposite of less than equal. Now have we gone far enough that I've managed to give y'all syntax errors? So there's something called a trivial expression. I don't think I asked about it on my exam, probably in the Mind tab. A trivial expression is something that's always true. So what's a trivial expression? Trivial expression is something like this. If, I'm going to put this back in the comments, so I'm going to delete those triple quotes. If 3 less than 4. Trivial expression because it's always true. So there's no reason to write a trivial expression, with one exception. If you boil it down, and you want to do this, while true, keep repeating. That true is actually a trivial expression, but it serves a purpose. It keeps the loop repeating. True is a trivial expression, but it's okay because it keeps the loop repeating. It's going to be an infinite loop unless we find some way of getting out of it. We add a return statement or a break or something that kills a loop. So if you're writing code and something is always true, then you probably didn't need to make it an if. If something is always false, then there's probably a logic error involved, right? If my program never printed out that it was cold, no matter what the temperature was, then it's probably a logic error. So these are calling them equivalency operators. Equivalency is equal, equal. I guess I could go back and update our notes to that effect. I'm going to come back up here, scroll, 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 and I'm going to call equal to, I'm going to say equivalency operator. Am I ever going to call it that again? Is it going to show up on the exam as that? No. Note that the book uses a single equal, but every language I've ever used uses double equal to check for equivalency. Just because the book was written generically, right? And maybe there are languages that use that, so. It'd be neat if you could buy this text and it was customized for your language of choice, right? But instead they show examples in C++ and Java and Python and stuff. I guess that's good. If you're trying to learn a second language, you could refer to this textbook. We know what less than, we know what greater than means. We know what greater than and equal. We know what less than, equal, and here's the one that the book calls that, but we call that the not equal to operator. I'm going to go back and make absolutely sure that I have the words not equal to on that. Yes, I do. So this says any decision can be made with only these three operators, these three comparisons. Now it suggests that not equal makes it harder to think about. And so their recommendation is to use not equal only for single alternatives. So use not equal, according to the book, in only single alternative ifs with no else's. I'll give you an example of that. And I don't always buy it, but I'll show you, right? If x not equal to 0, do y, else do z. You could have reworded it. You could have said, if x equals 0, do z, else do y. Right? That worked just as well. And logically, our brain likes thinking of that more than it likes that. We like thinking in positives. Positives are easy to understand. If we throw too many knots into a expression, it becomes more difficult to understand. That's why when you're writing English, you're generally encouraged to not use double negatives, right? Especially if the meaning of the words you're using is somewhat nebulous. I ain't not going to the store. All right, that means you are going to the store or you're not going to the store, right? Kind of slang, but ain't not means am not, right? Or are not. So if we parse that out, I am not going to the store, which means I am going to the store, you know. That may not be what you mean if you said it that way, right? But grammatically, that's how you would interpret. But, you know, that makes it hard to understand. If we wanted to be absolutely clear and not use, you know, vernacular slang, then we would just say, I am going to the store. Unless we were trying to say something for, you know, effect, right? I am not going to stay home, right, you know, and sure, whatever. Now, maybe there are times when you want to word it like that. The book is just recommending you do that. When we get to the not keyword, then if you throw too many nots into an equation, it can be difficult to understand. If not x equals y and not a or b, right? Something like that. That's like, what? You probably ought to find a way to rewrite that. Because the computer will parse it just fine, but if you didn't understand it while you were writing it, you may have written the expression wrong. And if somebody comes along and tries to figure out what you meant, you know, logically you can dissect that and you could write and you could come up with a way of writing it that makes makes it a lot clearer. If I had to rewrite that, I'm going to take a stab at it. And has higher precedence than or. And this is just a thought exercise. It's not anything that you're going to see on the exam. But and has higher precedence than or, and I'll go back and I'll show you why in a minute. So, I think that's true. And it's just like if you have 2 times x plus y, you could expand that to 2x plus 2y, right? That's a distributive property or something like that. We could take that not outside of this. And it becomes if not x equals y or a or b. It's still not real readable. Not digging it. Okay, I'm going to change my equation just a little bit. A equals b, a equals b, a equals b. I took that last word out. Okay. So, that is a lot easier to understand, at least in my mind. This one is a lot easier to understand than this. Or you could rewrite it like this. And this isn't a logic class, so I'm not going to make y'all do this on your own. You could say, you could use the not equal to operator. If x not equal to y and a not equal to b, now I've gotten lost. I believe that to be correct. I'm not absolutely sure. see if you had too many knots in it if I'd written it differently to begin with. I'm not absolutely sure that this is equivalent to this. I may have broken my logic somewhere. I think we're okay though. I think I got it right. And that is maybe the easiest to understand. X better not be equal to Y. A better not equal to B. But if both of those cases are true, X is not greater than Y, greater than equal to Y, and A is not equal to B, right? Then we're going to do something. All right. Sorry for all that writing. Oh, wasn't strictly necessary for you to put all that in the notes, but I know some people like to be very meticulous and put in everything that I write. It's okay. Common errors. Don't use greater than when you mean less than. All right. Another error. Thinking you can do this. If 0 less than x less than 10. Right? Looks great. That's how we did it in some of our classes in junior high or something like that. But you can't do that. What you got to do instead, if 0 is less than x and x is less than 10. So this is wrong. And this is correct. This is checking to see if something is within a range. If you're checking to see if something is within a range, you use AND. If you check in a range, use AND. What if you want to see if it's outside the range? You want to see if it's 0 or below. Or if you want to see if it's 10 or greater. Then you would use OR. You could just slap a knot on it and put parentheses, but we're going to ignore that because we don't like knots. If x is less than or equal to 0, or x is greater than equal to 10, then it's out of range. So to see if something is out of range, you use OR. So let's give some examples of that. Again, I'm going to use like the military, and I don't really know the rules. Let's say that you're allowed to enlist in the Marines if you're between 18 and 30. Wouldn't take long to Google it, but just pretend that's correct. So we would ask for the age. Print, what is your age? End quote, in parentheses. Then get the input. Age equals input, parentheses, in parentheses. Then we would need to convert it to a number. Age equals float, parentheses, age. Then we could write an if statement to see whether they can join. So if the assignment was, write an if to see if something is within that marine's age limits. All right, and we're going to do that. If age, what's our lower limit? 18. If age is greater than or equal to 18, and we have to use and if it's within limits, within a range, and age is less than or equal to 30, colon, print, you may join the Marines. Now we're going to write an if to see if age is outside the age limits. So if age is less than 18 or age is greater than 30, we have a problem. Print, can't join the Marines. And yes, there are other ways you could do that. You could have an if and then you could have an else, or you could stick a not in there or something like that. But in general, that's the simplest way of expressing it. All right, so I'm going to come up with some silly limits for our homework. Ask for density. And we're going to pretend that the density is in grams per cubic centimeters. But that doesn't matter. Just ask what the density is. Or you can, ask for density in grams per cubic centimeters if we want to make it correct. And what we're going to do is we're going to say if density, we're going to say the range for floating is 0.8 to 1.2. If it's less than 0.8, this is stupid. It's not necessarily true. It sinks. No, that's not true. If it's greater, if it's less than 0.8, it floats into the sky. If it is between 0.8 and 1.2, it floats. If it is greater than 1.2, it sinks. Again, that's not right. Let's just roll with it. Let's pretend that's correct. Don't memorize those numbers and take it to a physics or chemistry professor or he'll laugh at me. So, you're going to ask for the density. Once you have gotten the density, do these things. 1, check to see if it is within range and print it floats. I better make this second statement here, it floats in water, right? We had 3 cases. Print it floats in water. Else, print it doesn't. So we're checking to see if something is within range. And then we're going to check to see if it's outside of range. But don't do it just by elsing this particular one. Check to see if it is out of range. Right, if it's either that one or that one. And if so, print. It either sinks or floats in the air. So one of these is a dual alternative if, one is a single alternative if. This is the exact message that I want it to print. It either sinks or floats in the air. And this needs to be print, it floats in water. Okay. So, that one's pretty short, hopefully. If you get stuck, ask me about it. We'll have a week to work on it. I've been doing a subtle review as we go through this. But let's see if there's any other quiz questions exam questions I want to warn you about. It's open book. You can load up C-Engage, load up the PowerPoints, load up any homework you've written. So the other classes already had this exam, so I've kind of ironed out the bugs in it. All right, know what pseudocode looks like, right? Pseudocode has a word start, it has a stop. Let's just do that. Know what pseudocode looks like, and Python and flowcharts. Three different kinds of errors. Know the difference between a syntax error versus a runtime error versus a logic error. Now, I believe the textbook calls both of these things logic errors. And so if you kind of goof a little bit and you call them both logic errors, I'll probably give you credit. But you know what a syntax error is, right? It's a typo, that kind of thing, right? A runtime error stops the program, right? A program crashes. And then a logic error is it just does the wrong thing. It prints that it's cold when we typed in a temperature of 200 degrees. Know the difference between strings, floats, and Boolean values and integers, right? So if I have 4 versus 4.0 versus 4 versus the word false, which one of these is a string? Strings have quotes around them, right? Which one is an integer? Integers don't have decimal points. Floats do have decimal points. So, integers are whole numbers. Floats have decimal points. And Boolean values are true falses. Strings have quotes. Please remember PEMDAS. I'm not going to even go over it. Order of operations. Right? Parentheses, exponents, and then multiplication and division, and then addition and subtraction. Which of these is floor division.
Is the double?
Yep. Double slash is floor division. It means round down. Then there is a single slash. That's just regular division. And then what's percent? Modulus, which gives you the remainder. So if you have 7 divided by 4, I can't think like that. How about 9 divided by 2? That's equal to 4.5, right? 9 floor division 2 means divide and round down. So what's it equal to? 4. And then 9 modulus 2 means after you divided the 2 into 9, you had a remainder. What's the remainder? Don't say 0.5.
It's 1, right?
Right, it had a remainder of 1. 2 goes into 9 4 times with a remainder of 1. All right, 1 plus 2, this is known as addition, obviously. But Bob plus Sam, that is not addition, right? That's concatenation, fancy Latin word for appending. So if you have strings, it does appending, it does concatenation. There will be a simple flow chart. It just has a single if branch in it and no loops. So you ought to be able to rock it. The turtle question. Yeah, there's a turtle question, but just one. If you have something that has 4 forward commands in it, it's going to be a square, right? Draw a line, turn an angle, draw a line, turn an angle, draw a line. If it's got 3 forward commands, it's drawing a triangle. If it's got 5 forward commands, it's a pentagon. No, it's not. Yeah, a pentagon, right? So, 3 forwards make a triangle in general. 4 make a square or something like that. 5 make a pentagon, and so on. Just because I'm going to give you some code and I'm going to ask you what shape it draws, I don't want you to type it in, right? You're not going to type in a 20-line turtle program just to find out it makes a square or something. What is the definition of syntax? Technical definition are the rules of the language. Syntax is the rules and grammar of the language. We're just about done with this. Couple more. We've talked about sentinel values so many times. A sentinel value. It's a value that ends the input. Is Python a high-level language or a low-level language? Those words have very specific meaning. High-level means it's got English-like words in it, and algebra. And it's got English-like words, while, if, and stuff like that. So Python is a high-level language. Why do you modularize? You make reusable code. You can put that module in something else. It aids in abstraction, right? You can think of the big picture. I don't have to know how to make the turtle go forward. I can just tell it to go forward. And it allows teams of programmers to work on the same code. You write this module, you write the other. So, every variable's got certain attributes. They have attributes like name. What's another one? Value. What's something else that a variable has? Well, it's got a variable name, it's got a variable value, and when we did this up here, what distinguishes these variables from each other? One's a float, one's an int. What's a collective term for that? Type. So, variables have attributes. They have names, they have types, they have values. There's a fourth one, which is memory address. Not going to write that one down.
I was gonna say location, but I guess.
Location and memory would be one of them. And so if I just asked you to enumerate them and you listed them, then I would count it, but it's like a multiple choice kind of question or something. I don't put that there. I think I'm going to take that question out. So there's a term for ignoring the details while thinking of the big picture. It's called abstraction. Abstract, right? You're thinking abstractly. I'm going to get the input, I'm going to calculate the speed of light, and I'm going to produce the output. Okay, that's abstract, right? Then you go and you provide the details, and it's not abstract anymore. So just look up the definition of abstraction. And that's it. That's pretty much the entire exam, although I left some things out, right? Some specifics. Let's make a Dropbox. Then I can pull the notes back up if you need them.